In this video, we're going to look at factoring all types. Kind of go through all the types I went through in the videos before this. When we look at this, we want to be able to recognize the type of factoring that we're doing. So let's talk about the types. This one here, we have x squared minus 9x plus 8. That's definitely got three terms. And it has an x squared with an x in the middle, so that one is called a trinomial. Now, the type of trinomial is going to be a simple type because there's a 1 in front of it. The 1 in front of it means it's a simple type, so we're just looking at what multiplies to 8 and adds to the negative 9. Same with number 2, we've got a simple type trinomial, so it's 1 in front of the x squared, it's x squared, x in the middle, and just a number with no x. Contrast that to number 3. So let's talk about the types, and then I'm going to go and solve them. So here, number 3, I have a 3 in front of it, which makes it not simple, because it's got 3x squared plus 6x plus 9. But when I'm reading that to myself, so whenever you do these questions, you kind of want to read it to yourself, talk to yourself a little bit in your head and go, 3, 6, 9. 3, 6, 9, those all have a 3 in common. So I'm going to do common factor first. And then if I take the 3 away, I'm going to see if it's still a simple type or not a simple type. Right? So I will look at that. Okay, look at the 3. Here, I go 5a squared minus 45. I only see two terms with a minus between. So with a minus in between, that means it's going to be a difference, but those are not perfect squares. But can you see that there's a 5a squared minus 45? There's a 5 in there. So with each one of these, you kind of analyze them to see whether or not it's which type. So let's start with these 4, because I looked at those to compare. I'm going to answer them, and then we're going to look and compare the next set, and then do that again. Right? So let's do this in bits. So this first one here, I'm going to rewrite it. And I'm going to write it down here. So number 1 is x squared minus 9x plus 8. Okay, and then number 2, I'm going to do that one over here, x squared minus 5x plus 14. So when you get a nice big worksheet like this, you're working it on yourself, on your own paper, and then you've got these lovely questions to use. And you can use them again later for review. So let's come back to that. So this one here, we looked at it and we said, okay, the first number in front is a 1, and it's a trinomial, x squared, 9x, and 8. So the key thing with the trinomials is that we have double the number here compared to there. So we know that this can be broken up into the 2 brackets. So when you break it up into the 2 brackets, you've got this, 2 binomials. Now, because it's an x squared, we don't really have to do this big X thing, because it'll just be an x and an x. You can if you want. If you're like, oh, I just do it for all of them, that's fine. But on the side here, this left side will always be my first number here. So that left side here. Then this one will always be, oh, that's not a good color. It's just a light blue, so I'll do it in pink. So this one here goes onto this side. So the 8 is either going to be 1 and 8 or 2 and 4. Those are sets, right? So it's either these 2 or those 2. Now, if I put 1 and 8 here, am I going to be able to get a 9? Yes, I am. So it's a 1 and an 8. And that would be getting me a 9. A 2 and a 4 won't get me the 9 in the middle, so that's the 1 and the 8. So this is the crisscross. You don't have to do it this way because of the simple. Because it's a simple trinomial with a 1 in front, I can go right ahead and just write the x's here. And then you're doing the thought process of what 2 numbers multiply to 8 and add to negative 9. And that can only be 1 and 8. So you don't have to draw it here if it's a simple trinomial. Okay, so we're kind of going over the types and the strategy. So then I would say, okay, it multiplies to 8. When I see that it multiplies to 8, then I know that it is going to be 2 positives. So I'm going to take this here, okay, and I'm going to take this part here and go, I know that that's 2 positives or 2 negatives to get to a positive. When I multiply to get to a positive. Is it going to be 2 positives or 2 negatives? I look, so use your eyes. There's your eyes, and there you're happy because you're doing math, and you're looking here at the middle one. And you go right here, I see that it's a negative. Since it's a negative, look, eyelashes, happy, happy. Okay, you've got negative, so is it going to be 2 positives to get the 8 or 2 negatives to get the 8? It has to be the 2 negatives because it adds to be a negative. So -1, -8. The signs are really important. I always have students say, okay, I've got the numbers right, but I'm getting the signs wrong. The signs are really important, so you need to take another minute and think of the signs. You don't want to just, okay, I've got the numbers, close enough with the signs. Without the signs, it's still not quite there. Okay, so we're going to try that again. So we got this one. Because it's a simple one with the 1 coefficient, then I'm going to go like this. I'm going to go 2 brackets, like that. And we're going to see x and an x like that. Okay, x times x. That'll get me my x squared. I have a positive 14. Okay, so then I know that, so I don't have to do this because it's just an x and an x. You're just doing it straight on here. You can if you want, but I know it's going to be 1 and 14. Will that get me 5? So I know it's 1 and 14 or 2 and 7. Those are my only options, that one or that one. They're matching pairs, so the only way I'm going to get 5 is if it's a negative, so make sure you look at the signs. The signs are really important. Without the signs, it's still not quite there. So we want a -7 because we want it to end with a bigger negative number and a positive 2. So that makes it a -7 and a positive 2. Now, will that work? Will that get me a 14? Okay, so look one more time, so slow it down. I know for this it has to be a positive, positive, or negative, negative. Most people put that answer down. They go, yes, but it's a positive 2 and -7 gets me the -5. But you have to look at the multiplication first. It's positive 14, which means these are the only 2 sets of numbers you can have. 2 positive numbers or 2 negative. I can't use 1 and 14. Can I use 2 and 7 in any positive way? Both of them, or negative? No. So this is not possible. Okay? So we can find the numbers, and reversing the signs won't change anything. We can't do it because of the signs. So the signs, as I was saying, are really, really important. You can't say that I've got it except for the signs. We want to get you to, I've got it and my signs are always correct. Okay, so you cannot work it if it doesn't have the right signs. Now, number 3, we looked at when we began. I said, let's look at the types. So trinomial, trinomial. 1, 2, 3 terms. It's x squared, x9. This looks like it's the harder type of trinomial because it's a 3 in front. But when I said 3x squared, read it to yourself really slowly. 3x squared, 6x, and 9. They all have a 3. They all have a 3 there. So that means it's a common factor of 3 first. So take the 3 out, write down what's left over. So 3 from here gets me a 2x, and 3 from here gets me a 3. Okay, so then, now look, this 3 is going to sit in front and wait. I want to factor the rest of it. That is now 1, 2, 3 terms. It's an x squared, x with a number. That is a trinomial. Is it the simple type or the harder type? It's a 1 in front, so it's a simple type. So I don't have to do the x because I know it's just going to be x and x on the left side. Okay, and then that means it's going to multiply to 3 and add to 2. Okay, multiply to 3 and add to 2. So what multiplies to 3 and adds to 2? Right, so we got 1, 3, and that's it. So 1 and 3, so we only have that choice, only if the 3 is positive and the 1 is negative. Now, one more time. Don't ever do anything until you've checked the sign. For this here, I need positive, positive, or negative, negative to multiply to be a positive. I can only do this if they're opposite signs. So again, do not say, and I'm just pointing this out, don't say not factorable. But this line has to go away, right? So that line, we are going to erase it, right? You're not going to work in marker. We're going to erase it from your work. I want it gone from your work. Erase it. And then you stop here. Okay, so stop there. In your brain, you go stop. That is beautiful. Stop there. Okay, so you could only do don't say, people say not possible. It is. You took a 3 out. That's already possible, but you couldn't go further. So you were able to do one step. So don't say not possible, because we did do one, but we couldn't do the second one and do this one again. But that's okay. We did one step. It was fine. Okay, so this is beautiful. Stop there. It's factored, common factor. And the common factor is gorgeous, and we're going to leave it like that. Not every trinomial is factorable. Number 4. Number 4 was 5a squared minus 45. So what I talked about was 2 terms. 1 term, 2 terms. Remember, terms are linked by multiplication, so that's 1 term, that's another. It's not going to be a trinomial, simple or the more difficult trinomial, but it could be a difference of squares because there's a minus in between, so you have to look here. But those are not perfect squares. They have to be perfect squares. So let's take out the common factor of 5. Okay, and what do I mean by perfect square? This is what I mean by perfect square. That's a times an a, and that's a 3 times a 3. A perfect square has to be exactly the same numbers. So then that means knowing my difference of squares. So the pattern with this was whenever you have a perfect square and a perfect square number, that's 3 times 3, we break them apart evenly. A times a gets me a squared. 3 times 3 gets me 9. They're identical. And the sign in the middle are opposite. Those two signs are opposite. And that's fully factored. You had a common factor first and then a difference of squares. Okay, let's go back to the sheet. So we talked about this one, trinomial. We thought it was a harder trinomial, but it was actually common factor by difference of squares. Difference of squares. So remember, this is called difference, okay, which means it has to be a minus of squares, right? So the difference here has to be happening right there, and they have to be perfect squares between them, or beside them. Okay, so that's difference of squares. Now, when we come back here, we go number 5. 5 has got xy squared minus 9xy plus 8y cubed. Right away between all, how many terms? 1, 2, 3 terms. Between the 3 terms, I can see an x, no. Oh, there's a y. There's one y there. There's a y there. I can take out a common factor of y. Okay, so let's start with that. So we're going to write down the question, xy squared minus 9xy plus 8y cubed. So I see a common factor of y. Write down what's left over. I can't take out x from all of them, so I can go xy. This one, I'm going to take out the y, so I'm left with 9x. The y went out here. And this is 8y squared. Now, I know that this is a trinomial, but is it my perfectly patterned trinomial? It has to be double here and then a single here. I have a y squared here, no y there, and there's no double x. So this one here is done. There's no pattern here that I can do a trinomial, so it doesn't work out like one of those. So we stop there. Now 6. We look again. We go trinomial. 1, 2, 3. Look at the pattern. X squared, x, no x. So that's my trinomial. So I'm going to write that down. This one to me looks like the harder trinomial. Okay? The more challenging trinomial. Okay, because it's got a 15 in front. When it has a number in front that's not 1, you got to do a little bit of work. So this is the big X trinomial, right? You can call it that one. So the big X here means you got to do the big X on the side. So we're going to do this here. I can't common factor anything out. They're not the same for any of them. 15. Okay, so let's grab this guy. This 15 goes here. So that always goes on that side. And then this here, this minus 14, that goes to this side. So the 15, right, is this part here, and then the 14 fills in the right side, right, left, right. So left here. So for the 15, you have 2 choices. you have either 1 and 15 or 3, 5. Okay, so those two are those two. I'm not going to start with the 1 and the 15 because 15 times anything is pretty big. So let me just wait on that one. Okay, I'm going to just start with the 3. So let's do 3x and 5x. 3x and 5x. So that's the first term right here. Okay, so this one here, the first term, we grab it and put it on this left side. The 14 is going to be 114 or 27. This set or that set. Now, you can put the 1 here and the 14 here, but right away you can see that's quite a big number, right? It's 42. That could possibly work. Let's see, because it's a 29 in the middle. It's a pretty big number there. So let's do that. So 114. So you go crisscross. The crisscross that we're getting is this arc. 1, 2, 3, 4. So when you multiply, that's a crisscross. So we're going to go 3 times 14, so 30, 42x, and 5 times 1, 5x. Can I combine that to get a 29? No. Can't do that 29, so I'm going to switch it. 14 and 1. 5 times 14 is pretty large. It's 50, 70, 70. So I'm not going to try that because, look, I already tried it. There's no way I'm going to get 29 out of that. So then you go, okay. So then my next possibility will be 2, 7. So I can either do 2 here and 7 here. So 3x, 7, 21, 5 times 2, 10. So 21 and 10. I can't get 29 out of that. So you keep doing this. Switch it, 7, 2. Don't switch to the left side, just the right side, because otherwise you're double switching. 3 times 2 is 6, x, and then 5 times 7 is 35x. Can I get a 29 out of 6 and 35? Yes, I can. Okay, how do I get it? 29 would be positive 35 minus 6. Okay, so then you go back here. Find me, wait, let's check this one more time. So if it's a minus, I know it must be a plus minus. And does that check out here? Yes, so thinking, these parts in the circles, you don't have to write any of this part. So you're thinking a positive, negative, yes, perfect. So this would be the 6 is 3 times 2, so that's negative, negative 6. And the 35 is 5 times 7, so that's positive. So you rewrite it, and you go 3x. Remember, these are the brackets, because the crisscross is the FOIL that we're doing there. 3 times negative 2, 3x minus, or positive 7, and then 5x minus 2. Okay, so that's using the big X. You had to use it then. Okay. Number 7. When I look at this, I go, okay, that's a trinomial. That's a trinomial with a number in front, a more fun trinomial. This one here has 4 terms. 1, 2, 3, 4. 4 terms. So I'm going to write that down. AC plus MD plus AD plus MC. Now, think about this and go, okay, if there's 4 terms, the only thing we know how to do is a 2 by 2. So 2 by 2. So you can do these 2 terms together, factor them, and then factor those separately. Is there anything to factor here, though? ACMD, nothing. How about here? ADMC, no, nothing. Can we reorder this? You are allowed to reorder it. So I'll do 1 with 3 and then 2 with D. AC plus AD plus MD plus MC. There you go. And now try again. Can you factor something out of here, those 2? AC, AD, you can factor out the A. You're left with, if I take out A, CD. Here, MD, MC, I can take out an M, and I'm left with D plus C. So let's try that, because that does sound promising. So we're going to take out an A, and we're left with C plus D. I'm going to take out an M, and we're left with d plus c. And you go, ah, darn, they're not the same. Aren't they supposed to be the same? They are, except c plus d and d plus c are actually the same, right? So if you rewrite this, c plus d plus, what did you hang on here? C plus d. We hung on to this one because we went, wait, do this. So hang on to this one and say, wait, I want to look at this again. Those two are actually the same. You can rewrite it. You don't have to. You don't have to show the step, but I'm just showing you, look, c plus d and d plus c, I didn't change anything, so you know that they're the same. You can skip this step and go, okay, if those are the same, here, right, c plus d, d plus c. Hang on there. So we're going to take out this common one. Now, remember, when you take out the common one, I'm going to emphasize this. When you take it out, you're taking it out once. You're only taking it out once. C plus D, and then you're writing what's left over. So it's like you're picking things out. These are two groups, two terms here. These two groups are both donating to you in your finger the C plus D. So you're going to pick this one up, put it to the side. This one also put it to the side. It feels like you have two of them, but you both donated the same amount. So on the side, you're just going to say you each donated a C plus D, and I'm hanging on to it here. What I have left over is A plus M. Okay, so we grab that one. You grab this one here, C plus D. And you see I'm going to grab it from both of you. We're going to put it to the side, and look, C plus D times A plus M. So remember, when you distribute, you're doing C plus D times both of them. They both get it back. But when you take it out of the bracket, you're taking it one time. A lot of people want to take two. You're just taking it out once. Think about it this way. Sometimes you can see it better when it's not so busy. If I said AX plus AM, or sorry, right, one more time. If I said to you AX plus MX, right? If I said that, the common would be the X, right? That's common. And then you go, okay, I'm going to take out what's common once, and then I'm going to write what's left over. Because you know the check is that when you distribute, they would both get one back again. So it's the same thing here. The yellow is like the X. So AX plus MX, I need to get rid of that, so I'm going to take it out one time and leave what's left over. Okay. Let's look at one more. Now we go to number 8. 8 is 27m cubed n squared minus 15m squared n cubed. So when you look at this, you go, it's two terms. There's a minus in between it, but are these guys perfect squares? 27, perfect square is, what's a perfect square again? 4 is a perfect square, 2 times 2. 3 times 3 is 9. 1 is a perfect square, 1 times 1. 3 times 3, 4 times 4 is 16. 5 times, 16, 5, 25. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 36. 7 times 7, 49. Okay, those are all perfect squares. So that's a perfect square. So take a look. Is, what number are we on again? 8, 27, or 15 perfect squares? No. So then we'll go 27m cubed n squared minus 15m squared n cubed. And we go, okay, but those guys are not perfect squares. Not perfect squares. So I cannot do my perfectly square factoring, but they have a common factor of 27 and 15, both of them have a common factor of 3. And then this, they both have m, so m, I have 3 of them here, 2 of them here, so I'm going to take out 2 to be fair. And n, I have 2 and 3, so n squared. What do we have left over is 9m minus 5, and then I took out 2, so I had 1 n left. And then you look at that and go, can I factor that anymore? Is that a difference of squares? There's a difference, there's two terms, but 9 is a perfect square, but m is not. M is not m times m. 5 is not a perfect square. It should be 25, but not 5. And that's not a perfect square. I've only got one of them. I can't break it into two terms. Okay? So we stop here. It was just common, and you're good to go. Okay, I'm going to stop the video here, and there's going to be more. So we're going to do more in another video.